Hello everyone, today we shall be learning how to calculate the length of an arc of a curve. Consider this arbitrary curve that I have shown on the screen. I have marked 2 points on the curve A and B with the corresponding x-axis coordinate being x1 and x2. Now let us mark 2 points on this curve that we are going to say are extremely close together. The first point is going to be denoted as P and the second point going to be denoted as Q. And this length between P and Q, that tiny arc, I'm going to call it delta S. Now we can safely say that the entire arc S from A to B is made out of these tiny delta S segments. So if we add up each of these delta S segments, we are going to get S, the value of the arc, the length of the arc from A to B. Therefore, we can say that S is equal to sigma from x equals x1 to x equals x2 delta S. So as you can see here, to find S, what we are going to need is delta S. So now let's compute delta S, find an expression for delta S. Consider this section. Let's redraw it over here. So that curve is going to be something like that, with this point being Q and this point being P. And let's say that this length and this length is called delta X and delta Y respectively. So this is delta S. Since delta S is an extremely small length, it is safe to say that this is a right angle triangle, and therefore the Pythagoras theorem applies here. Therefore, we can write that delta S squared is equal to delta X squared plus delta Y squared. Next, let's simplify this by firstly dividing both sides by delta X squared. That gives us delta S over delta X whole thing squared equals 1 plus delta Y over delta S whole thing squared. Now to subject delta S, let's take the square root on both sides. That gives us delta S over delta X equals 1 plus delta Y over delta S delta X whole thing squared, the entire thing raised to the power half, which is the same thing as taking the square root. And then we just simply take this delta X to the opposite side to get delta S equals 1 plus delta Y over delta X squared, the entire thing raised to the power half into delta X. Now that we have an expression for delta S, we can substitute it to this derivation that we have over here. So that gives us S equals sigma from x equals x1 to x2, and we just write this here, 1 plus delta Y over delta X squared, entire thing raised to the power of half delta X. Now to actually compute this, we are going to set delta X to 0. So that's going to give us the limit S equals limit delta X goes to 0. So that basically means that this point P and Q is going to come infinitely closer to each other, such that it's going to become a single point. And we are going to add up all of those infinite points on this arc all the way from x1 point A to x2 point B. And that addition is going to give us the length of S. So we're going to set delta x to 0 using our limits and simply just rewrite that here. X equals x1 to x2, 1 plus delta y over delta x squared, the entire thing raised to the power half delta x. We know that when delta y over delta x is sent to 0, we get dy by dx. So we can compute this limit using integration. And that gives us s equals, the summation becomes an integration. Therefore, the integration sign from x1 to x2, 1 plus delta y or delta x becomes dy by dx square, entire thing raised to the power of half dx. And this is the equation that we are going to use to calculate the arc length of a curve. Let's box that up, since this is a very important result in calculus. Now, to understand how we are going to use this equation, let us consider an example. Let's get into it. Let's consider this example. Y equals x squared is the curve, and we need to find the length of the arc of this curve from x equals 0 to x equals 1, which is basically from the origin to the point where x equals 1. So the first step is to basically write down our formula. S equals integration from x1 to x2, 1 plus dy by dx squared, entire thing raised to the power of half dx. So as you can see, what we are going to need for this is dy by dx. So we do that. We compute dy by dx. dy by dx is equal to 2x, since y is equal to x squared. Now we simply substitute that value into this equation, and that gives us s equals integration. x1 is 0 in this case, x2 is 1 in this case, 1 plus 2x squared, entire thing squared, raised to the power half dx. Now here we are going to need a substitution to compute this integral. Let us consider that 2x equals sine u. So if we differentiate with respect to x on both sides, we get 2 equals cos u du by dx. And therefore, dx is equal to 1 over 2 cos u du. We use this substitution into this integration. And therefore, we get s equals integration from, let's just disregard the limits for now and try to compute the integral. Integral 1 plus sine u squared, we get the square root of that, dx. So if we substitute for dx, that's going to be equal to integral 1 plus sine u squared raised to the power half, and dx is going to be equal to half, so I'm going to put the constant in front over here, cos u du. Now we know that this particular component, 1 plus sine square u, this is equal to cos squared u. This is because cos squared u minus sine squared u equals 1 due to that identity. Therefore, this can be written as half integration. So if this is cos squared u, because of the where we raise it to the power of half, this becomes cos u, and cos u into cos u is equal to cos squared u. So we write cos squared u du. And this next can be written as 1 over 2 into 1 over 2 integration 1 plus cos 2u du. And this is possible because we know through the identity cos u squared equals half into 1 plus cos 2u. And therefore, we can simplify and write this as 1 over 4 integration 1 plus cos 2u du. Now let us consider s. S is equal, we can now add the limits. So we know that x is equal to half sine u. So to get this in terms of u, we need u equals sine inverse 2x. So sine inverse to 0, so when we substitute 0 here, we get u equals 0. And therefore the limit here, the lower limit is 0. When we substitute 1 here, it's 2. So the upper limit is sine inverse 2. And here we basically write down what we had here. So we had 1 over 4 as a constant outside. 1 plus cos 2u du. And now we can integrate this. This is equal to 1 over 4. So 1 we are going to get as u when we integrate it, plus cos 2u when you integrate it, you get half sine 2u. When we apply the limits, that's going to give us, the limits are sine inverse 2 and 0, the lower limit. This is going to give us, when we substitute the values, 1 over 4. So u is going to be sine inverse 2. And then here we are going to get plus 1 over 2 square root of 5. So this is the answer, and this is the length of the arc of the curve y equals x squared between x equals 0 and x equals 1. I hope you understood how we derived and then used the equation to calculate the arc length of a curve. If you have any questions or doubts, please feel free to post them in the comment section. That's it for this video. Thank you.